You're listening to Linked AM. Tell your story on Linked Live and get noticed. You're listening to Carl Wolfenden on the Business Class Show and is not always affiliated with the guests and the topics discussed. Any financial statements are the opinions of the individual, and you should seek professional advice before making any decisions. Upgrade your listening to Business Class, the show that puts you in the big leather comfy seats. So sit back and enjoy our take on the trending business issues of the week.
Howdy, folks. Here he is, the Texas Brit, the guy with the stiff upper lip, filling his 10-gallon hat and his cowboy boots, Carl Wolfenden.
Good morning, and welcome to Linked AM here on Business Class News. And you know me. You've been listening to me for years now. I mean, this is about our 8th year now that we've been on air. And my passion, and we've really brought it to the forefront over the past couple of years. Really since the pandemic hit. As soon as we said, we're going to do this, the pandemic hit. But it was about the future of the workforce. And, in that journey over the past 2 years, I've met some fantastic people. And of course, one of those people was Michael Steiner of Best Robotics. And he and I have had many conversations on air where we've talked about, different ways that employers are actually looking at the future workforce, etc., and really sort of start to frame out that how that future workforce is going to take place. So he introduced me to my next guest, Mike Bright, of course, who is the professor and chair, I'm reading this, of electrical and computer engineering at Grove City College in Grove City, Pennsylvania. Mike, thank you for joining me today.
It's a delight to be here, Carl, and I appreciate your show.
Oh, well, it's great. I mean, you sent me your resume. And it was, oh my goodness me! Your experience and your sort of your richness of things that you've been doing over the past, and you're only 21, so I don't know how you crammed it all in
for the third time.
Well, tell me about Grove City College, and the School of Engineering there. What do you do there?
Well, first, let me just comment. Resumes are normally one page, maybe two if you really go. On the academic side, we basically say, I was first in my class at kindergarten at putting the blocks on top of each other. We have every accomplishment that's ever been done in mankind's history. So they come across a little bit better than they really are.
No, I know you're a very accomplished person. So yeah, tell me more about what you guys do over at Grove City.
Sure. Grove City College, an hour north of Pittsburgh, Pennsylvania. We're a small liberal arts college. We're explicitly Christian. But one of the things that drew me to the place was we have this classic liberal arts focus, but they've always included the professional programs in there. Strong business program, strong entrepreneurship program, mechanical engineering, electrical engineering, computer science. So it's not just the philosophical humanities kind of thing. We truly are the liberal arts. We have all the pieces we put together. And it has been a great place for me. Our School of Engineering, like I say, we've got mechanical engineering, electrical engineering. We're just starting up computer engineering. We've got computer science. But we have engineers that have to take a liberal arts curriculum so they have a full exposure to the other side of the world. They're excellent with their math, with their science, with their engineering techniques, but they can put that all into a bigger perspective of how that fits into the world.
So you and I have had many conversations off mic, because, my passion is technology, innovation, etc. But the role of the engineer has changed. So what do you focus on when you are teaching this? You say that they have that roundedness of experience that you try and put them in front of.
20 years ago, we had a fighting chance as engineering professors to give the students all the knowledge, all the skills they needed for a career in engineering. That no longer exists. Studies tell us that the students graduating from my institution are going to have 7 to 11 completely separate careers in their life. The best we can do is teach them how to teach themselves, how to learn, give them that curiosity to continue to grow, to expand. You're aware of technology, it's constantly changing. And we just have to make them nimble enough to get along there. Now, part of that human side is humans change much slower than technology. And so you have to understand, how are we making this technology that fits well with the humans that we're making this for? My particular field, electrical and computer engineering, is incredibly broad. And so there's all these different subspecialties and all these very specific skills that they need. All we can do in 4 years is give them a solid base. Here's a broad set of knowledge that you're going to be able to apply. We're very project focused so that they're learning how a project works. And in every project, they have to learn a new skill or a new tool or a new idea. And we're building that into them. Every project you do for the rest of your life, you're going to be learning something new along the way. So, will this be on the final exam? Yes, every bit of it will be on the final exam, just not necessarily in the form you're seeing it now. So that, and I mentioned we're explicitly Christian place. Engineers in particular take ethics very seriously. Every engineering society out there has a code of ethics. Every one of those code of ethics says you owe your employer some things, that as an engineer, you will use your skills for the benefit of humanity, for the welfare of everyone. And we're very intentional here, and we weave that into a variety of classes. It's very explicit in a number. So we want them using technology to solve the right problems to help people.
Absolutely. And we've talked about that. When you touched on that, when we were chatting, and when we said we got to talk, we got to get you on as a guest, that is a very big, a part of engineering that we talked about. When you invent something, and the innovation, innovation can be very powerful, but it can also be very destructive if used in a sort of unethical way. So you're absolutely right. Engineers have a sort of a purpose to actually make sure that does not go over that line. And if you identify it, because somebody can invent something and then it be taken completely out of context of what it was originally designed for.
One of the conversations I have with my students is, you create a technology and you put that into the user's hands, and the users have responsibility to use that for its intended purpose, to not subvert it to some evil or bad purpose. But I instill in them, they as the engineers, it's not that this technology is neutral. You need to build into it. Here, we're solving the right problem in the first place. And we're building it in such a way that it's easy to use for a good purpose and difficult to use for a bad purpose.
Yeah, absolutely. Now, I've got to ask you a question. We've had conversation with Michael and some of your other colleagues over there, because I know you're involved with Best Robotics. We'll talk about that in a second. But have you seen like an increase or decrease in the amount of people that want to go into engineering? Because I know there's been a gap identified, but is that something that you've seen?
The gap is still huge. The opportunities for employment for my graduates is just phenomenal. These things go in cycles. Mechanical engineering has been up in enrollment for a few years. I think they're starting to moderate. Electrical engineering has been down for a bit, but that seems to be rising. But we're not producing nearly enough engineers for the demand that's out there. Industry is just hungry for people that can solve problems. And again, people that can come in and take a problem and say, well, I know how to do that piece. I know how to do that piece. I don't know that one or that one, but I know how to learn how to do that. And we will figure it out. And they want people that are just very creative. And I mentioned before, they're nimble, they're able to pivot. We're headed this direction. The technology, new technologies came up. Well, we need to shift gears and go with the flow.
So large corporations, that are out there, they're competing with the nimble, smaller startups, etc. What do you think is the opportunity? Is it should you focus on going into large industry, or should you look at these startups, or is there not really a sort of a focus that somebody that wants to go into engineering should take? I'm just curious.
Sure. Beginning of my career, I spent 13 years at IBM, kind of the model big. But any big business that's still in business today, and many of them are not, they have had to adopt some of that small startup nimble mentality. They've remade themselves. I look at IBM now, and it is utterly and completely different than the company that I worked for. One of those 21 age years ago.
21 years ago, absolutely.
But I spend a lot of time talking to the companies that are going to hire my graduates, that employ my undergraduates for the summer. And it's very interesting. I'm talking to engineering companies that they're deeply involved in technology. And every one of them starts to talk about several other aspects first. They talk about communication. The day of the engineer that is a geek and a nerd that can't speak to people, that can't understand people, is gone. They need people who can communicate orally, that can write persuasively, that is able to put together a business pitch that makes sense not only to the business, but to the customer that we're trying to sell that to. They want people with that broader perspective. Yes, you have the technical skills to design this little circuit board that goes onto a bigger piece that goes into the solution. But do you understand what the entire thing is going to do for people? So again, they're very human focused. And then, oh yeah, they have to know calculus, differential equations, electrical circuits, electromagnetic theory, and all that other stuff. And it's funny, it's like, well, that's a lot of hard stuff, but they really are looking for a much broader skill set today. And they need an engineer that does understand all of the technical pieces, but can put that in the right perspective to solve the problems that we need to solve.
See, I think that segues nicely. I was going to ask you about, Best Robotics, because I know you were involved in Best Robotics. You were the president as such. And I know you're still involved, etc. And Michael had talked about on a couple of shows prior to you coming on the show about how you take these young students and you put them through a program over a period of time that make them aware that there are different elements of an overall project. And so you've got the marketing side, you've got the presentation side, you've got the how do you present, the idea, how do you document it, etc. So that's like from the ground level all the way through, and then they get to experience all of this. So in terms of what you're seeing from middle school through to high school, is that are they teaching that type of thing, or is this needed to be taught?
Well, in 2008, 2009, I was looking for some way to connect our engineering program with local schools as an admissions thing. We wanted to attract those students to come in. The first pitch I heard about Best Robotics was exactly what I just said. What are my companies looking for when I get them done with college? What do I want for them coming in? I want them to be able to communicate, to be able to stand up and give a persuasive talk, to be able to write their thoughts down in a coherent way, to understand the marketing, the business side of the thing. But at the end of the day, in Best Robotics, they still have to build a robot that obeys the laws of physics. They have to use math. They have to do the calculations. So again, they're producing that rounded individual with that project-based experience. And one of the things they quickly learn is the first robot they build is going to fail. And
Right.
they have to
Yep.
figure out, okay, well, now we have to pivot. We have to do this a little bit differently. And when I'm talking to new schools, that's one of the selling points. When you're sitting in school and the teacher asks a question, you know that there's one right answer. If I don't get that right answer, then I've failed. And I tell them, guess what? Here in Best Robotics, we want you to fail. We want you to fail repeatedly. But every time you fail, you analyze what went wrong. You think about the perspective. You say, okay, how can we fix that? And let's make it better the next time. And let's make it better the next time. And let's make it better the next time. And I talk to the teams that come and participate here. And they had a group of students that had this idea for a robotic arm. And they had another group of students with a different idea. Which idea is better? Try it out. Test it in the real world. See how it works. And let the real world decide which is the best idea. And inevitably, the best idea is pieces of both. Yeah, you got this piece right, but boy, if we put this wrist on the end of the arm like my idea was, that turns out to be a winning combination. And that's exactly the kind of creativity, the perseverance, because, none of us likes to fail. But if we learn how to fail well, then they're going to be great engineers. And that's exactly the people I want coming in. They've learned the math, they've learned the science, but they've learned in the perspective of a bigger context of the project itself. And I've been delighted with the progress we've made with Best Robotics here. And as you mentioned, I've played a role with the national organization, and we've gotten some great students out of it. But it's also the human side, and anybody that hangs around Best, and you've talked with Michael, we just have lots of great human stories. The robotics team is often the home for the wayward children that couldn't find a home with this group, that group, or the other. But here in the robotics team, if you're willing to try, if you're willing to work, if you have a spark of creativity, we've got a place for you. And I've just seen students just light up and get excited and become engaged with school. And those are the students I want, the excited, the ones that are into it, that are creative, that they're engaged.
Well, I think, we talked about it at the top of the hour, didn't we? When we talked about how, you have to have this roundedness. And what I love about what I've heard about what Best does is that you learn to become part of a team.
Yes.
And engineers have this stereotype sort of persona of being very isolated and sort of, but they're not now.
Not now.
My next question is, what is the future of engineering look like? But I think we've talked about it. It's not just innovative idea. It's about putting together a team that is going to actually, create something that has an output that has, as you say, a human benefit at the end of it.
One of the taglines for my students, my generation picked off all the problems that one person could solve in a reasonable amount of time. So those problems are all gone. The only problems that are left are problems that are big and they're complicated. It's going to take a team and it's going to take years. And frankly, we did all the easy ones. The only ones left are the impossible ones. So you all have to figure that out. Another thing I talk with students about, to be an engineer, it helps to be brilliant. I have some students in class, they just eat calculus for lunch, and we throw electromagnetic theory at them and they go, yeah, that's fine, that's great. But when I talk to employers, a lot of them like a B student. A student that had to work, that had to struggle, that they got the assignment in class that I have no idea how to do that, or that just looks impossible. But perseverance, they took it, they said, okay, I can solve this little piece of it. Okay, well, I got that. And then I chew away at the next piece, and I chew at the next piece, and the problem will not beat me. I'm just going to take that problem and I'm going to chew it and try it and try this solution, try that solution, fail, until we succeed and the problem is solved. And that's the kind of student that had to struggle to get there that a lot of engineering companies want, because they're solving problems that are impossible. And so they want somebody that's solved impossible problems before, because I will not let it beat me.
Yep. Yep, that's an attitude I think is instilled with everybody that I think touches your department, and that actually the whole sector of engineering. So unfortunately, we're coming to the end of our little conversation here, but in summary, I love how you just positioned how it's the journey that you take a student through. And their mentality of how they come into the program. It's not just about this, it's about this. It's about team as such.
Yes.
What would you do? What's your suggestion? What is your advice to somebody listening to this, maybe a parent of a kid that wants to get into engineering and innovation, or somebody that's actually in a sector now where they want to advance themselves in innovation? What's your advice to them?
Find a team. You've mentioned that's just critical. If you have a creative idea, go with it and try it, and it will fail. And you pick yourself up, dust yourself off, analyze what went wrong. How can I do that a little bit differently? And just keep plugging away. Entrepreneurs, every successful entrepreneur, what are we talking? Well, I failed at this, I failed at this, I failed at this, I failed at this. And then I finally succeeded, and it was a radical success, and it changed everything. So find a team, inspire them. And again, you have to be able to communicate to inspire them, but go for it. Try it.
Love it. Mike, I thank you for joining me this morning. As we've talked about, as we said, off mic and everything, and I knew that everything we were going to talk about on this little segment was going to excite me and excite the audience out there. And I'm going to put all the information about Grove City College on the post that goes with this podcast, as well as the video that we'll be sharing. And again, I appreciate for everything that you do for the students, and also for the future of humanity, because technology is part of that, but it's got the human element to it as well. So thank you, Mike.
Thank you, Carl. I appreciate the opportunity.
Of course, that was Mike Bright of Grove City College in Pennsylvania, Grove City, Pennsylvania. And if you've been listening to some of the other segments that we've been doing, you'll understand how excited I am and why I'm excited, because a lot of the things that Mike's been talking to me about, as I say, out of the studio, it really sort of connects everything together. And I encourage you to go and check out Grove City College and see what they're doing there, the mechanical electrical engineering side, and also with the best robotics program that Mike was involved in as well. And I put all the details below this post. And as I always say, go out there, have some fun, go and invent something, but have some fun and make some money, because of course this is business class news. And so you're going to go out there, but at the same time, be safe. So until the next time, have a great rest of the week, and I'll see you next time. Cheers. Bye-bye.